Uh, Again, we'll go to the normal random variables, and now we'll discuss the normal curve that has been used widely actually in all our studies. And this curve actually, or this population, if it follow normal curve or normal curve, the measurement is or randomly selected individual from the population, then X, which is the measurement for the random selected individual, said to be normal random variable and also said to be normal distribution or normally distributed. normal distribution معناته موزع توزيع طبيعي. Any random variable can be completely characterized by its mean, mu, standard deviation, and sigma. And we do need to understand that if you want to characterize any normal random variable, you do need to look for the mean or mu or standard deviation or sigma. Now I want you to differentiate between mu and the mean and also the standard deviation, which is S, okay, and also sigma. Now if we are talking about a certain population or sampling, we draw a sample from large population, we call it mean, just only mean, okay. But if you draw the whole population, infinite population, okay, we can call it mu. It is also the same for the standard deviation and sigma. Sigma refers to the large population and standard deviation just only S, okay, because it's sampling, okay, which is the square root of the variance, okay. We draw the sample from the large population. So we are working in sample. The differences between them just only if we draw a sample from the large population, we call it X bar or the mean, not mu, okay. And also we call it S, which is standard deviation, not sigma. Sigma refer and also mu refer to the large population mean and large population standard deviation. So those are the main characteristics for the random variable. If we want to deal with them and see their normality, okay, or to test them. We do need to know also there's a lot of different normal distributions actually. There is not just only one normal distribution. The curve can be seen also in different ways, in different curves actually. Depending on the mean and the standard deviation. As you see, this is the main differences between the normal distribution differences. This curve, for example, someone is the mean of a certain curve is or normal distribution is a certain value. Another value of mean will differ in its shape also, and also another standard deviation will affect all the shape of the normal distribution. So the standard normal distribution is a normal probability distribution. It's a probability, as I said previously, that has a mean of 0 and a standard deviation of 1. The total area under or below the density curve is 1. You do need to know that the probability or the area under the curve is 1 with mean equal to 0 and standard deviation equal to 1. This is the standard normal distribution curve. This is the standard normal distribution curve. If you deal with the standard normal distribution curve, you do need to know that it has a 0 mean, 1 standard deviation, okay, and the total area below the curve or the line is 1. Those are the main characteristics of the standard normal distribution curve. And the normality density can be given by this formula. This formula given that fx equal to 1 divided by square root of 2 by sigma e to the power of minus x minus mu, okay, to the power of 2 over sigma square, given that x is larger than minus infinity and below infinity. In the equation, you can see that pi here and e are constant, equal to 3.14 and 2.71 for pi and e. You don't need to use this formula to know the normal density of the curve. We have a certain characteristics for the normal distribution curve that can be summarized in those points. As you see, it is a bell-shaped curve and symmetric. Symmetric it means انه متناظر من الجهتين, and also bell shape, شكله زي الناقوس المقلوب لكنه okay. the mean والmedian والmode also are all equal. This is the main characteristics of the normal curve. The highest frequency in the middle, because you can see the curve is high in the middle, okay, and the frequency gradually tapers off as the scores approaches to the ends, okay. It will go in the high curve, okay. In the middle, the curve will be large, okay, you can see, and it will be tapered off as the approaches the end of the curve. The curve approaches but never meet. They will not be able to meet with each other, and the abscissa at both high and low ends. It should be like this. Those are the main characteristics of the normal distribution, or normal characteristics of the normal distribution curve. Let us summarize it again. It's a bell shape, symmetric shape, okay. Mean, median, and mode are equal. Highest frequency in the middle, and also the frequency gradually tapers off as reaching the ends of the approaches to the end, and also the curve approaches but never meet with each other, the abscissa at both high and low ends. Those are the main characteristics of the normal distribution curve, and we can walk in the coming slide. We can deal with such characteristics. Now, this is the shape of the normal distribution curve. This is the typical shape of the normal distribution curve, as you see here. But you do need to know, as we summarized previously, that this curve has standard normal distribution curve has a mean of 0 and sigma equal to 1, okay, and the area below the curve is equal to 1. All of them are probabilities. So now, if we erect the perpendiculars a distance of 1, 2, or 3 standard deviation, what will happen to the surface area, or the area below the curve? As you see here, if we move just only 1 standard deviation unit, and given that you do need to know the surface area below the curve is just only 1, okay, the mean equal to 0 and sigma equal to 1. Now, if we move below or above the perpendicular, the mean actually just only 1 standard deviation unit, you can see that we will cover on both sides, okay. Now this line, or this perpendicular, is just only 1 standard deviation. The area in the middle will cover about 68% of the total area below the curve, and also in the two ends, as you see here, it will cover 0.16 and 0.16. If you sum all those values together, you will see that all of them equal to 1. So just only if we move below or above the mean just only 1 standard deviation, it means that we are talking about 68% of the total area below the curve, and the rest will be distributed to the two ends. Now, this is just only in case of 1 standard deviation unit. Now, if we go 2 standard deviations, we will cover 95%, and the two ends will be divided to 2.025 and 2.025. It means, and also again, if we sum those areas, the 3 areas with each other, those areas, it will be equal to 1. Now, if we're moving just only 2 standard deviation above or below the mean, it means we are talking about 95%. of the total area. But if we go just only 3 standard deviations, as you see here, we will cover 99.7% of the total area, and the rest will go to the two ends, which is about 0.0015. This is the main area, and how can we deal with those things? Because the standard deviation, actually, if you go back to my lectures, previous lecture in the class, you can see that we discuss how can we obtain the variance, how can we obtain the mean, how can we obtain the mode and the median, and also how can we deal with such standard deviation, and why do we need, how can we use the standard deviation and the variance in our daily life and daily activities. Actually, this is the main thing, but the normal distribution curve here give us the main idea between, because we are dealing with 1 as a total area, 100% at a total area below the curve, and we will divide it according to our movement below or above the mean in general, 1 standard, 2 standard, or 3 standard deviations units.